Hey everybody, Mr. Mark with you with a second projectile motion example that we're going to do together. And here we have our same motorcycle stunt person driving off the roof of a building again. This time it's a 28-meter tall building, so a little bit taller than the last one. At some unknown velocity v0 that we're going to try to find. We have this hoop that we place over here, 18 meters away from the edge of the roof, and our goal is for this motorcycle rider to go right through the center of the hoop. So the hoop is 6 meters above the ground, as we have here on our figure, and then this hoop is a square whose sides are 4 meters long. So that means that this side of the square is 4, so halfway would be the center, and so the height of our center of our hoop, because we want to hit the middle of this thing, half of a 4 meter square, 4 meter side square would be 2, so 2 plus 6 would be 8. So we want to hit a height of 8 meters with our motorcycle, so we want the path to look like this. Hit the middle of that hoop. So in order to do that, we have to have just the right velocity. If we're going too fast, we'll go over the hoop. If we're going too slow, we'll go underneath the hoop. We want to go right through the hoop because the hoop is on fire. And if we don't hit it right, bad things are going to happen. So here's our table. And again, you can do a table and kind of keep things organized this way if it's helpful for you, but it's not necessary once you kind of get the hang of these things. And so I'm going to go ahead and call the initial height of our motorcycle a position y equals 0 and make this hoop center height my final y. That way, down is my positive y direction, and I don't have any negative signs. Since I'm going down, and down is positive, and my acceleration is down, I'm going to call that plus g, or plus 10 meters per second squared for my acceleration. And then my initial velocity vertically is 0 since this motorcycle is being launched horizontally. So kind of the first thing I got to figure out is what is y? Well, if the building is 28 meters tall and my hoop center is 8 meters tall, the difference would be from here to here 20 meters. Just 28 minus 8, and that's how far my motorcycle has to fall. And so my final y is going to be 20 meters like that. In the horizontal direction, x, this velocity is the thing I'm looking for. And since it's being launched horizontally, that's equivalent to vx. Delta x, my hoop is 18 meters away. And very similar to many other situations, if we knew the time, we could figure out what Vx is by doing delta x over delta t, since the x velocity is constant. So I'm going to go ahead and set this up. 18 meters is my delta x, and then we're just going to have to do something else to figure out our delta t. Then the y direction, I know everything that I need to know to figure out how long it's going to take to reach the center of the hoop. So we can do our vertical equation, and again, that's the 1/2 at squared kinematic equation, like that. And since the initial velocity is 0, initial position is 0, those first two terms go away, and so I get y equals 1/2 gt squared again. And then solving that for t, multiply both sides by 2, divide by g, take the square root, be 2y over g, like that. Okay, so t equals square root, so 2, and then my y is 20 meters. That's how far my motorcycle has to fall. And this is on Earth, so g is 10 meters per second squared. It's almost like somebody carefully thought out the numbers on this one, because that's 40 over 10, which is 4, and the square root of 4 is 2. It's going to take exactly 2 seconds to reach the center of that hoop. So up here, Now that I know what delta t is, I just plug that into our velocity in the x direction. And 18 divided by 2 would be 9. And then my unit is meters over second. So this motorcyclist, if they went exactly 9 meters per second, would go right through the middle of the hoop. If they went significantly more, they would go over. Significantly less, they would go under. Only 9 meters per second will cause us to hit the center of the hoop. I hope you found this warm-up helpful. Again, please do not try driving motorcycles off the roof of buildings on your own unless you are a trained professional stuntman like myself. But please do the physics at home, or in class, as it were. Till next time, ta-ta.